All right, so today's lesson, we're going to continue with solving inequalities, and we're going to look at two-step inequalities. And the good thing is that solving two-step inequalities is really no different than what we've done so far with solving inequalities. It's still the same as solving a two-step equation, as what you see there. So remember, we're going to do the opposite of PEMDAS. So we're going to add or subtract first. We're basically going to get rid of the number that's by itself. So not the number that's with the variable, but the number that's by itself. Add or subtract that first to get that off the same side, and then we'll multiply or divide to get the number away from the x. Remember, the same rule that we talked about with our last lesson still applies. If you multiply or divide by a negative number to get rid of something, you've got to flip the inequality sign. And so we're going to be solving these two-step inequalities. Just like we solved two-step equations, we'll be graphing the solution set. So really, it's not much different. With nothing brand new. The rules that we follow, how we solve everything, graphing the solution set, that's all what we've been talking about for the past couple of weeks, whether it's equations or inequalities. So we'll go ahead and get started and look at our first example. So we've got 3x plus 4 is greater than or equal to 16. So remember, we want to get rid of the number that's just by itself. Okay, so save the 3 with 3x. Save that for the last part. Let's get rid of that plus 4. To get rid of plus 4, we would subtract 4 on both sides. Okay, so plus 4 minus 4 cancels off. We're left with 3x, still greater than or equal to 16 minus 4 is 12. Okay, I'll write that up here. We divide, x, or the 3's cancel out. We're left with x is greater than or equal to 4. Remember, I did not have to flip my sign because I didn't divide or multiply by a negative number. So we'll graph the solution set. At 4, I've got greater than or equal to, which means it's going to be a closed circle. And then x is greater than means we shade to the right. Think about on a number line, all the numbers that are greater than 4, 5, 6, 7, 8, 9 would be to the right of 4. So that's our solution set and the graph of it. Okay, so we'll look at our next one there. 8 minus 2x is greater than 24. Now, first thing to remember is this minus sign goes with the 2x. It does not go with the 8. So we want to get rid of this 8 first. It's a positive 8, and the opposite of positive 8 is minus 8 or negative 8. Okay, so that's going to cancel off that 8. We're going to subtract 8 on the other side. So what are we left with on the left-hand side? Well, it's negative or minus 2x. Make sure that you write that because when solving inequalities, that does make a difference. Okay, negative 2x is greater than 16. So how would we get rid of that negative 2 that's with the x? Well, remember, we don't add it because this is negative 2 times x, and negative 2 times something to get rid of it. We're going to do the opposite, which is divide both sides by negative 2. So the negative 2's cancel out. I'm left with x, but what else do I have to do? If I divided both sides by a negative number, I need to flip the sign and make that less than 16 divided by 2, negative 8. So x is less than negative 8 would be my solution set. So whenever I go to graph this, at negative 8, it's just less than, there's no equal to, so it's going to be an open circle. And now x is less than negative 8. Less than, remember, we shade to the left, where the two L's go together. Okay, so open circle, shade to the left there. All right, let's look at our next example. So we've got x over 2 minus 5 is less than negative 8. So you see this over 2. If I started by getting rid of this 2 and multiplied both sides by 2, that is almost always going to get me the wrong answer. Okay, so you got it because it's very particular in the order that you go in. So this is why I say to make sure you add or subtract first. We're going to get rid of this minus 5. The way that we get rid of the minus 5 would be to add 5 on both sides. Okay, so the minus 5 plus 5 cancels out to get me 0. I'm left with x over 2 is less than negative 8 plus 5 would be negative 3. So I'll write that up here and we can finish out. Now, how would you get rid of that over 2? Well, this is the same thing as saying x divided by 2. The opposite of dividing would be multiplying. So I'm going to multiply both sides by a positive 2. Do I need to flip the sign if I multiply by 2? Correct answer would be no, I do not, because I multiplied by a positive number. So I still get a -6 as my answer, but the answer part doesn't really matter as far as flipping the sign. I multiplied by +2, which means I keep the sign the same. So x is less than -6. That means at -6, it's just less than, so it's an open circle. Less than means I shade to the left. Okay, so open circle, shade to the left. And we'll do one more together. That 7 minus 4x is greater than or equal to 11. So I want to get rid of this 7 first. It's a positive 7. To get rid of a positive 7, I would subtract 7 on both sides. Okay, so that's going to leave me with minus 4x is greater than or equal to 11 minus 7 would be 4. To get rid of that -4 or that -4, I need to divide both sides by -4 because this is -4 times x. The -4s would cancel off. I'm left with just an x, but since I divided by -4, I need to flip the sign, make it less than or equal to. And then 4 divided by -4 would give me -1. So x is less than or equal to -1. That would be my solution set. So at -1, open or close circle. It'd be a closed circle because it is less than or equal to. And then it's less than, which means I'm going to shade to the left. So really, if you forget to flip the inequality sign, that's going to mess up your answer, but it's also going to mess up how you shade your graph. So you will miss some points there. Make sure that you pay attention and correctly flip the sign whenever you multiply or divide by a negative number. All right, so I want you to do these two on your own. So go ahead and pause the video, do those two on your own, and then we'll come back and look at them together in a second. Okay, so 8 minus y over 3 is less than or equal to 5. This one's kind of tricky. Remember though, add or subtract first. I would be subtracting 8 because I want to get rid of that positive 8. So subtract 8 on both sides. That cancels this off. Now notice what I'm left with on the left-hand side. Minus y over 3 is less than or equal to 5 minus 8 is -3. Okay, so how would I get rid of this 3? Well, to get rid of the 3, I would multiply both sides by 3. Okay, but if I multiply both sides by 3, what is still going to be left in front of the y? Well, there'd be that negative sign still left in front of the y. So could I do anything as I multiply 3 to get rid of the 3 and the negative sign? Multiply by -3, because what's a negative times a negative? Well, a negative times a negative is going to give you a positive. And so that's not only going to cancel off the 3's, it's going to cancel off the negative. So anytime you've got a negative sign and you've got to multiply by a number to get rid of it, if you multiply by -3, negative whatever, that's going to cancel off everything. And what's the only thing I'm left with on that left-hand side? Well, it would just be a positive y. Now, since I changed it and multiplied both sides by -3, don't forget to also change the inequality sign and make it greater than or equal to. And then -3 times -3 would be +9. So my solution set there would be y is greater than or equal to +9. Okay, so I go ahead at 9. It's going to be a closed circle because it's greater than or equal to. Greater than means I would shade to the right. Okay, so that's what my solution set and the graph is going to look like for that one. Okay, and then the last one, we've got 6 plus 3t is less than 9. So I'm going to get rid of the 6 first. I need to subtract 6 because it's a positive 6. So that's going to cancel that off. I'm left with positive 3t is less than 9 minus 6 would be 3. 3t is less than 3. And then to get rid of that 3 in front of the t, I'm going to divide both sides by 3. And that's going to leave me with t is less than 1. So I do not need to flip the sign because I divided by a positive 3. So at 1, it's just a less than, so I'm going to have an open circle and then shade to the left. Open circle, shaded to the left. Okay, so that's solving these two-step inequalities. Once again, the same way that we solved two-step equations last week, and then we just graph the solution set, flip the inequality sign only if we multiply or divide by a negative number. One last one that we'll look at, and that is writing an inequality, and this is going to be a two-step inequality. So remember this. So let's read it first. The product of -2 and a number -6 is greater than -18. Well, I know that a number means x, and I also see that I've got greater than, so that's going to be my inequality sign. So let's just go ahead and take it one step at a time and look and see at how this is going to look. The product means what operation? Means multiplication. So the product of -2 and a number, -2 times x. We write -2 times x as -2x -6 is greater than -18. So -2x -6 is greater than -18. That would be our inequality. Okay, so to solve that, we're going to add 6 to both sides. That's going to get us -2x is greater than -18 plus +6 would be -12. And then to get rid of that -2, we're going to divide both sides by -2. And that means what else do we need to do? We need to flip our inequality sign and make it less than. -12 divided by -2 would be +6. So x is less than +6. That would be our solution set. If I were to graph this, tell me, would it be an open, closed circle, and which way would I shade? It'd be an open circle, and I would shade to the left because x is less than. So that would be writing a two-step inequality and then solving it and just knowing what you would have to do if you had to graph it. Okay, so we got some questions to work on in our books. Go ahead and work on those. And then we've got one more lesson talking about inequalities.